The discoveries coming from the James Webb Space Telescope are reaching down to the floor beneath physics itself. They are the kind of discoveries that force Nobel Prize winners to go quiet in interviews, that make cosmologists close their laptops and whisper, "This doesn't make sense." They make even the most confident defenders of the Big Bang stop mid-sentence, because the data they are seeing simply should not exist. And the James Webb Space Telescope has just delivered exactly that kind of discovery. Something so profoundly contradictory, so violently incompatible with our current theories of galaxy formation, cosmic evolution, and the origin of matter itself, that scientists are being forced to admit, reluctantly, nervously, and in some cases publicly, that something may be fundamentally wrong with the way we understand the early universe. Webb looked deeper than any instrument in human history. It looked beyond the cosmic dark ages, into a region where the first flickers of starlight were supposed to appear. Instead of finding faint, primitive baby galaxies slowly forming out of hydrogen clouds, Webb found monsters, hyperbright, perfectly structured, impossibly massive objects that should not exist for another billion years. These objects are not behaving like galaxies. They are not forming like galaxies, not evolving like galaxies, and may not even be galaxies at all. As these images arrived one after another, each breaking a different piece of the cosmological model, one realization began spreading across the scientific community like a quiet shockwave. James Webb did not just reveal new objects. It shattered our understanding of physics. It all started with a single object, a small yellow blob hidden in one of Webb's deep-field images, barely noticeable among thousands of faint specks. There was no reason to think it was anything special. Nothing about it screamed cosmic anomaly, except for one detail that refused to be ignored. It was too bright. Not just slightly unusually bright. It was bright in a way that violated every luminosity model we have for the early universe. Astronomers initially assumed it was closer, perhaps a trick of distance, the kind of misjudgment that happens all the time in deep cosmology. But spectroscopy ruined that assumption instantly. The redshift was enormous. The distance was real. Suddenly, astronomers were staring at one of the most distant galaxies ever observed, existing when the universe was only about 290 million years old. But it didn't look like a baby galaxy. It didn't look primitive, small, or chaotic. It looked structured, massive, and fully formed. A veteran in an era where only newborns should exist. And this was the moment when panic began spreading quietly behind the scenes. Because if even one fully formed galaxy existed at that time, then something about our understanding of early universe physics would need to be reconsidered. And within days, Webb revealed that it wasn't alone. It wasn't a fluke or a one-off. It was the first in a flood of objects that appeared to challenge the rules in our cosmic playbook. Deep fields from James Webb are supposed to be windows into cosmic infancy, quiet, faint, scattered points of light, representing the earliest baby steps of structure formation. But when Webb turned its infrared eyes toward one of the darkest corners of the cosmos, what it saw was not infancy. It was maturity, activity, complexity. Webb found thousands of strange objects in these deep fields, and the more astronomers examined them, the more they realized they were not looking at the early galaxies they expected. These objects appeared too bright, too compact, too massive, and too organized. They did not neatly match the known forms of protogalaxies predicted by standard cosmology. And the worst part was that they appeared throughout the early universe. Not one anomaly, not two. An entire population of cosmic structures that seemed difficult to reconcile with the expected timeline. A recent study identified dozens of potential galaxies formed between roughly 200 and 400 million years after the Big Bang, a surprisingly large number that challenged existing models of galaxy formation. One of the study's authors admitted that even if only a few of these objects turn out to be real, scientists may need to rethink galaxy formation entirely. And this is the uncomfortable truth. Webb is not simply revealing a slow-growing universe. It is revealing a universe that may have developed much faster than expected. A universe that looks too old at the edges. A universe that matured too quickly. A universe behaving as if parts of the standard Big Bang timeline are incomplete, or at least in need of revision. As if bright, massive early objects weren't enough, Webb revealed something even more disturbing. observations that challenge our understanding of how efficiently galaxies can turn gas into stars. In galaxies today, only a fraction of their gas is converted into stars. That limitation is deeply embedded in astrophysics, but Webb has identified unusual early objects with extraordinarily high star formation efficiency, with some appearing to have converted nearly all of their available gas into stars. Every atom, every molecule, every particle participating in an intense burst of star formation. Under current models, this is extremely difficult to explain. A galaxy cannot simply burn through all of its material instantly. Gas needs time to cool, collapse, and fragment. Galaxies experience cycles of starburst and quenching. Yet some of Webb's early objects appear to behave as though they were assembled through a process very different from what we see in modern galaxies. These objects may not be behaving like ordinary galaxies at all. They could represent an unusual stage of galaxy formation that we do not yet fully understand. Some scientists have even considered whether these observations could point toward an unknown category of cosmic object, something that existed during a stage of cosmic evolution our current models do not adequately describe. And that possibility is more unsettling than any single anomaly, because it would mean we are not simply missing a few details. We may be missing an entire chapter of cosmic evolution. For almost a century, we have understood distant galaxies through the framework of an expanding universe. The farther away an object is, the faster its distance from us increases due to cosmic expansion.